Hey there, awesome physics students. Let's talk about magnetism. Now, you're probably familiar with magnetism because you've used refrigerator magnets or other kinds of magnets before. And so you've probably seen or familiar with the idea that magnets have a north pole and a south pole. And so they have two opposite sides, just in the similar way that electric dipoles have a positive charge and a negative charge close together, so they have a positive side and a negative side. And in fact, these are both called dipoles because they have two parts that are opposite polarity, a positive side and a negative side. However, magnets produce a magnetic field, and so they produce magnetic field lines that come out of the North Pole and go into the South Pole. And we usually use the letter B to indicate the magnetic field, whereas we would use the letter E for electric fields. And for our purposes, electric fields and magnetic fields are different kinds of fields. They are not the same kind of field. Now, there is a connection there, but we're not going to get into that right now for sure. Now, you're probably also familiar that if you took two magnets and you had one that has a north pole and a south pole, the north pole is going to be attracted to the south pole, right? So if I have magnets like this, they're going to be attracted together. And in fact, if you let these two stick together, they would merge into one giant magnet. And the idea here is that the south pole and the north pole that are touching in the middle will be merged, and the field lines are completely compressed or stuck together, and then the free ends have a north pole and a south pole, and now this just becomes one big giant dipole magnet, just like that. And in fact, if you think, well, I'm going to separate these two poles like a north pole and a south pole, and I'll get a monopole or a naked north pole and a naked south pole. If you try to do that, so if you have a north pole and a south pole and you try and break them apart, and so you cut it right here, then what you'll end up getting is you'll get another magnet that has a north pole and a south pole, and two magnets that have a dipole. And so what happens in the middle here is you get two new poles will emerge, and you'll be again stuck with a dipole. In fact, you can keep doing this to smaller and smaller bits, and you just can never separate these two. So in nature, we never see what's called a monopole, that is a north pole by itself. You always see a north pole and a south pole. That's called a dipole. It has two parts, di for two. Okay, we've probably mostly are familiar with the usefulness of magnetism from the Earth's magnetism. So if you think about the Earth and you have a compass on the surface of the Earth somewhere, the north pole of that compass will point towards the close to the geographic north pole and away from the south pole. And the reason for this is that when you take one of these little compasses here and you put it in the proximity of a magnet, the north pole will align itself and point towards along the magnetic field line. So what that means is that there's magnetic field lines here that are coming like this and like this. And to align itself, that magnetic field line must be pointing into the North Pole, which means, paradoxically, if you think of what's inside the Earth like a big giant magnet, that means that from a magnetic perspective, at least in physics, this is a south pole at the geographic North Pole and a North Pole, magnetic North Pole at the geographic South Pole. Now, they're not totally aligned with the rotation poles of the Earth, and so there's some slight misalignment, but because they're mostly aligned, the compass will mostly point towards the actual geographic physical North Pole rotation axis of the Earth. And so that's why magnets on the Earth are so useful. Okay, we're going to explore properties of this magnetic field and how they interact with other things like charges and current-carrying wires, rather than focusing on the force between two dipoles like this. All right, we'll see you later.